Okay, today we have a fantastic number of people here. We are we are very, very happy to see all of you. Thank you very much for joining us. This is our last community call for this year. It's a fourth community call. And I'm super proud to have David Dale joining us today as our special guest. And I'm also very happy to see all of you here. And I can't express all the feelings I have. Just please know that I'm super happy. And I hope that you're going to be happy too as well. So what we're going to talk today about, there are a few things. We want to talk about what we're shipping in the latest version of our library. Then we will have a talk by David. And then Oleg from our team, he will also talk a little bit more about our ongoing work on goal-oriented framework for building goal-oriented bots or skills called Gobot. And then there will be a wrap up and we will be able to have some Q&A session, talk, and so on. So, and to begin it, to start, I want to point out a couple of things. First is, what are we going to feel on January 1st, 2021? I'm sure we all feel like, oh my God, yes, it's over. It's really over. We've managed to survive this year. I mean, it's not a good joke, obviously. I have some friends who died because of coronavirus. Some people who went through very hard form of this disease. Some people who went through the light form and so on. So it's not a good joke. But in a way, for society and for all of us, it was a very huge test and a painful one. And I can't stop thinking that maybe it's just a wave one. And we don't know what the next year is going to prepare for us. But be assured that the first rule of the next year, we should never talk about 2020 again. And if you want to talk about 2020, there should be some good reasons. And one of the best reasons for talking about 2020 for us at DeepPavlov is we participated in Alexa Prize 3. We've got into Alexa Prize 4. And we also built Dream, which is our AI assistant demo that worked on our website for several months before we had to shut it down because of participating in Alexa Prize 4. And we also shipped several versions of our DeepPavlov library. And we also started an open source distribution of open source multi-skill AI assistant, which is free. You can use it as you want, as you wish. It has Apache 2.0 license, so you feel free to doing whatever you want with the system. And we're working really hard to make available components of our Alexa Prize 3 and our Dream AI assistant skills, annotators for you, so that you could build a multi-skill AI assistants. And for that, for us at DeepPavlov, 2020 is a year of lots of achievements. Now, with all of that said, let's talk a little bit about the stuff that we have in our current library. And before that, I want to start and talk a little bit about DP3000. This is something I'm super proud of myself, because if you go to GitHub DeepMeet assistant base, let me share that thing with you on the second screen. We have this distribution, we have this library, we have this repository, sorry. And we put here a lot of different cool things. Like you have several annotators. Some of them are going to be part of the DeepPavlov library very soon, like Intent Catcher. It's going to be released in this version of the library. Some of them, like entity linking, were already part of the library for a couple of months. Some of them are still on their path to be shipped as part of the library in the coming in the next year. We also have several skills. We have 3 skills for now. One is IEML for chit chat. It's a very simple chit chat skill. We have harvester's maintenance skill, which is a very simple goal-oriented skill available for you. And we also have a harvester's maintenance Gobot skill, which allows you to use our Gobot framework for building goal-oriented skills with DeepPavlov technology. And this is just the components of the DeepPavlov DP. But we also have some distributions. And sorry, clicked on the wrong link. So, and we have several distributions. We call them assistant dists, and that's why we call it assistant base, because our internal repository for Dream is called assistant, not DP. So we have 3 distributions for now. One is DeepPavlov DP base, which consists of just 2 skills. You can go look up in the pipeline conf, and we can see that we have like a couple skills here. And we have emotion classification as one of the annotators, and we also have spell preprocessing as annotator as well. And there are a couple more distributions here. You can pick any of them. I would probably want to play with Gobot base if you would want to use our goal-oriented framework for building multi-skill AI systems, for building goal-oriented skills for multi-skill AI systems. And in that case, you can just clone this whole thing, pick these 2 files, put them in their correct locations, and then you could use Gobot to build your goal-oriented skill. And if you want to play with more functionality, this is a rather experimental one. You can go to assistant base DeepPavlov, which means advanced, and there are a few more things for you to play with. So there is entity linking, there is sentence segmentation, there is our goal-oriented version of the skill, and that's about it for the time being. We are going to ship more system distributions in the next year. We are going to add more components to the system so that you could pick those up and build your own thing from it. But the whole point is very, very simple. Starting with like the last 2 weeks or something about that, you are able to clone this repository and start using it as a foundation for your open source free multi-skill AI system. You can start like we started building our Alexa Prize 3 social bot in the last year. And now you can do it on your own. You can pick some of these components. You can also use components from DeepPavlov library, and we will provide documentation how you can use different components in the system. So you don't have to be limited to the skills and annotators that are available right now in the library here. And in general, you will be able to build any kind of multi-skill AI assistant you want. Obviously, you'll have to write down some code for response selection, especially when you will have lots of different skills and so on. But in general, that's what you have available for yourself today. And as we are participating in Alexa Prize 4, we are building on top of this very same thing. Obviously, we have lots of skills. We have lots of annotators. But in general, that's what we are working on. That's that's how we started building our multi-skill AI assistant, and that's how you can build them. And we promise you that we will continue shipping new skills, new annotators for you, new distributions, and talk about them in blog and so on. We also have wiki, by the way. So you will have everything you need to build your multi-skill AI systems. So that's thing number 1 I wanted to talk about. And the second thing is what's coming in the .014 release of our library. In it, we have 4 things for you. We have components like that make up QBQA, our question-based, knowledge-based question answering model. We have entity linking and wiki parser decoupled into different components, so we can pick them up separately and use in your system. If you want to use them in multi-skill AI assistant, you usually want them to be decoupled, because then you can use entity linking as annotator. An example of that annotator, running as annotator, is already in that repository I just showcased to you a few minutes before. And you might want to work with wiki parser directly, so they could run Sparkle queries against the very same database, the very same copy wiki data that you also use to detect entities with entity linking. That's thing number 1. and it will come with a little bit better or improved documentation. Second, we will have better support for classification models coming from Hugging Face, and we will write down a blog post very soon about it too. We also have form filling in Gobot. Oleg Serikov showcased form filling in Gobot on last community call, and today he will showcase it once more, but this time you will be able to pick up the bits and experiment on your own. And finally, we will also release one of the components from Alexa Prize 3 social bot that we've built last year and this year called Intent Catcher. We also showcased you a couple of community calls ago, but now it's practically ready for the prime time, and we're happy that we can finally share it with you. And we have a lot of more cool things for you to share with. So we have actions support for Gobot. We are still working on our intent editor, and we continue working on even broader support for Hugging Face components in the DeepPavlov library. So we have a lot of things coming for the next release, and this release is gonna be out very, very soon. So that's about what's happening in this release. And now let me shut up for a moment and welcome again David Dale, who is going to give a talk about his experience of building multi-skill AI assistants called Alice at Yandex. David?
Yes, hi everyone. So let's start. I'm David Dale. Currently, I am research engineer in the Skoltech University and also a freelance developer, and most of my freelance development is concentrated about chatbots and skills for assistants. I have spent 2 years working on the Yandex Alice voice assistant, about which I'll talk today. Two main areas of my work were improving intent classification and building or improving some specific scenarios, like video for our smart speaker connected to the TV screens, taxi, and so-called morning show, a process in which Alice plays a role of an radio DJ. I have quit Yandex, but still build new skills for Alice and still love it deeply. So what is this Alice? It's a voice or text assistant, just like Alexa, Siri, but in Russian, and it's made by Yandex. Its first interface was a mobile application. In this screenshot, you can see a dialogue which starts as a chit chat and then continues with a goal-oriented scenario of getting some information. And 2 years ago, Yandex also has released its first smart speaker called Yandex Station, and currently there are lots of interfaces with which Alice works, like several mobile apps, several smart speakers, a desktop browser, and a car head, which is installed in Yandex car sharing system. And the goal is actually to create voice interfaces for everything, for multiple devices and for multiple processes and services. And actually, Yandex is moving to this goal because the Alice already has more than 30 million monthly users, more than 100 internal skills. It depends how you actually aggregate them, and several thousands public external skills. This year, Alice got a strong competitor, a voice assistant from Sber, and I hope that both assistants will benefit from this competition. The principal scheme of assistant, Alice, like any voice assistant, is this. As an input, it gets a voice query by the user. By the process called speech recognition, it's translated into text, and by the process called natural language understanding, this plain text is converted into some machine-readable format, which usually consists of intents, slots, entities, and some other important annotations. Then a module of the Alice's brain called Dialog Manager decides what to do with this information. It can call some backend API that does some useful things like search for music or calls for taxi or I don't know, reads you news. And using this information and the information from the query and from the context of the dialogue, it creates some data on which the response is based. Then another process called natural language generation actually generates the response, usually from templates, but not only. And this response is read by some text-to-speech engine, and the sound is played to user. And when we talk about these backend APIs, some of them, there may be another natural language processing modules which are specific to their particular skill, which is actually played right now in Alice. Some of them can actually be built using the DeepPavlov technology. And actually, lots of these skills are created and maintained by the external developers. And by external developers, I mean two groups of people. The first group is developers within Yandex, but not within the Alice team, like in the team of Yandex Taxi or Yandex Music or Yandex Weather or some other team, which provides a service which is a basis of Alice scenario. And another group of external developers are people outside of Yandex who create the so-called external skills, which are connected to Alice by a specific API, which is quite simple and about which I can talk a lot. When we talk about this process called natural language understanding, which is maybe the most difficult process in this whole scheme, if your assistant is large like Alice, this process is especially difficult. What does it actually look like? You have a request like, Alice, please order a taxi to Leo Tolstoy 16 at 16. And Alice should recognize that the goal of this whole phrase is to order a taxi. This goal is called intent. And it has some important pieces of information, like address, where to call the taxi. Address consists of the street and of the house. And also there is time, when to call the taxi. And it also consists of two parts, hours and minutes. So how to perform this translation from a text to some machine readable structure? If we talk about a production-ready virtual assistant, it must be easy to create new scenarios for this assistant with limited or no training data. In academy, when we talk about natural language understanding, usually there are data sets with which we can just train a machine learning model. In reality, when we create such scenarios, we can have no data and we need to still to somehow manage it. We also want to have a fast way to fix mistakes after releasing these new scenarios or enhancement to existing scenarios. And we want to fix these mistakes without generating new unexpected mistakes. And we want to have a way to guarantee correct understanding for some given query, because we want to be sure that we have fixed this bug. And this all brings us to the idea that we need very simple models for intent classification and slot tagging, like regular expressions. When you create a regular expression, you are pretty sure which text it will match. Or some more intricate version of them called constituency grammars. You can create such grammars which are like regular expressions on steroids, which can reuse some constructions and make them deeply embedded with each other. If you want a machine learning based classifier, you might want to use a k-nearest neighbor classifier or some classifier which is called one versus rest, which is aimed to recognizing one single intent. Why? Because if you have a single classifier to make all the work, you need to retrain it when you make a change in any of the existing scenarios, and it creates a lock And the neural taggers, if you want to solve the problem of tagging a sequence of words with some labels using machine learning, you also want to train them in an intent-specific framework. So when you change one intent, all other intents are not changed. When I talk about how this NLU actually is performed, I need to mention some steps. So the first step starts with query normalization. Like we want to find numbers in this query and replace their textual representation with digits, or maybe to strip the word Alice, which is the activation word. After we have normalized the string, we may want to do named entity recognition, like find names, addresses, numbers, currencies, etc. And in Yandex, it's mostly performed by brute force approach. So just create a large dictionary of all possible values of an entity, or create a grammar which describes all entities, like all currency values. But this problem can also be solved with machine learning if you don't have such a large dictionary. Another important part of NLU is anaphora resolution, where you find pronouns in the query and replace the pronouns with the objects that they represent. Like I can ask, where is the Novosibirsk, which is a city in Siberia? And then I can ask, what is the weather there? And Alice needs to understand that there is actually in Novosibirsk. So this is the problem of anaphora resolution. And after this, all these processes, our query has enough annotation to try to perform intent classification. And it is the main collision point between multiple skills, because on this stage, we need to decide with which skill we want to continue. And after we have decided it, we perform the word tagging to find some more entities which are specific to this intent. And when we have lots of hypotheses generated by neural taggers, we may filter them by context or by concordance between what entities are found. It is basically what we work with as NLU, but we also want manageable natural language generation for a assistant. And to discuss how we generate response, we need to discuss in more details how we select a response. So in Alice, the main framework for the goal-oriented scenarios was form filling dialog management. So in this form filling, for each intent, we have a form which is set of slots, set of entities with which the current scenarios work. Like if it's taxi scenario, then we can have time, we can have destination and departure points addresses, and we can have also some special entities like chair for children, or like class of the car that we want to get, or some other things that a user mentions when ordering a taxi. But at least 2 points, 2 slots are required, the destination and the departure points. So these slots can be filled with different values, with the previous form, the form from the previous turn of the dialog, or the current result of the tagger, which find the entities in the user utterance, or some other entities which are found in the content text of the dialog, or maybe output of the backend API that brings you some more information, like the address of the user from the database of addresses. And if some of the required slots are missing, the dialog manager decides to ask for their values. And if all the required slots are filled, the dialog manager usually performs some action and tells user about the result of the action. The response is most usually based on templates. In Yandex, we used Jinja-based templates, which you can have which you may have encountered if you work with a web development framework like Flask, but with some specific NLP extensions, like an extension for inflecting Russian words. And if you want your template-based response to be more variable, you can sample the synonyms or synonymic phrases from the template itself or from some handcrafted ontologies to make the replies differ from each other and create an impression of a live dialogue. When we talk about coordinating multiple scenarios, it's important to describe all the rules and ways to decide what to do next in a dialogue. And for this, it's important to understand a concept of scenario. Scenario can be viewed as a set of intents which are related to each other. And intent is a particular way to classify one utterance of a dialogue. Some intents are allowed only within a scenario, and some other intents can start a new scenario. Scenarios are selected usually sequentially because that's how it's convenient to think about them. So we have some particular utterance from the user, and the first question a dialog manager can ask is whether the current scenario can continue its work with the current query. And if it is true, then we just continue the current scenario. Like if the scenario asked for the name of the user, then any answer that contains a name would be a valid answer. And maybe if the answer doesn't contain a name, the right thing to do is to re-ask user, to ask user to just pronounce a name. So in this case, we just try to continue the current scenario. Or if we cannot continue the current scenario, we check whether the utterance looks like intent from some other scenario. And if it's true, we start this new scenario. And if it's not, we can create another check to see whether the utterance looks like a search query. Like some informative question, and if it is true, then we proceeded with a search engine. And actually, we started it working with a single search engine because actually Yandex is a search company. It has started as a search company, but actually we can try to search just over the whole internet or over all the music database or over the database of video or some other domain-specific search. And if the query doesn't look like a search query, we can try to answer it with a general conversation model. So when I left Yandex in the beginning of 2020, Alice didn't have any methods specific for recovering speech recognition errors. But Alice did have some set of methods to prevent these speech recognition errors. And this method includes adjusting the language model using by the speech recognition engine for the current context. So when, for example, a user has some devices in his or her smart home, the names of these devices are added and boosted in the this language model for the speech recognition, and they're recognized with higher probability, and it makes Alice avoid most of possible speech recognition errors with difficult names. So we have another problem. Sometimes multiple intents are likely. So, for example, I could ask Alice to turn on or to play a morning show, and maybe it means that I want to watch a movie called Morning Show, and maybe I want to run a scenario in which is Alice native scenario called Morning Show. So I need to somehow choose between them, and there is a way to create handcrafted rules for choosing scenarios, like forbidding or boosting some scenarios depending on the context. For example, if I have been searching for some point of interest on a map, then I am highly likely to call a taxi to the place. So the probability of choosing this scenario may get higher in this context. And some of the ambiguities can be resolved by a machine learning model. We used a gradient boosting based model, which scores potential scenarios based on the query and the response proposed by the scenario. So actually, it queries, it ranks responses of different scenarios, and it uses independent one versus rest classifiers. Each particular classifier predict the score of how relevant the answer by this scenario would be in this context, and the chosen scenario is the scenario which the highest predicted score. So by this method, Alice manages to choose among the competing scenarios. Some more ways of actually decoupling different scenarios or skills from each other are following. So as I said, Alice tries to use KNN or one versus rest ML-based classifiers for intents in order to allow changing a classifier for one intent without affecting all others, which is important where lots of teams works on lots of intents in parallel. And it's also important to allow committing new grammars, new taggers, new changes in the KNN index or new versions of this classifier asynchronously, so that we don't have to wait for one team to commit their model before training our own model. So it makes sense to split the model in the smallest possible number of pieces, which might still use common features. And another important step of decoupling these scenarios and allowing multiple teams work on them was to move huge scenarios into separate microservices with their own release cycle. Before this, all scenarios had the same release cycle and were tested and released simultaneously, which stopped some team who wanted faster release cycle and made other teams try to rush to get into a next release. And one more important idea is to treat answer selection as a search among possible scenarios and not as a classification, because when we try to classify texts, we believe that there is a single correct intent and other intents are wrong. But with lots of skills, you instead need to understand that there must be some correct answers or no correct answer at all, but some of them might be more or less relevant. So you need to have a way to somehow evaluate their relevance. And when you want to evaluate this, you can rank competing scenarios based on the end-to-end quality metric. In Yandex, it is formulated just as a human-provided score of the current answer of the dialogue assistant. So the target for the model that ranks these competing scenarios is the score which would be given if the current scenario answered. And of course, to obtain this score, you need to run lots of experiments trying to substitute one scenario for another and to see how good the answer would be. The last idea that I want to focus on is the external skills. You can treat them as bots within bot. For example, I could ask Alice, please ask McDonald's to deliver 2 cheeseburgers and cola light. So Alice is just the activation phrase for the assistant. McDonald's is the name of the skill. And my last query, the green text, is passed to the McDonald's skill, if it exists. And it's actually a separate web service that receives a JSON with the command and some metadata about the context about the command. And it forms a response as a JSON and sends it back to Alice, which reads it. And after the skill has been activated, it keeps responding all the utterances until the skill itself decides to exit, or the Alice decides to shut it down because it senses that user wants to exit, or because some other skill is more relevant, or just because of timeout. The challenging part is the skill discovery. So the first part is easy, and it has been released long ago. But the problem is that the users may not know the name of the skills or whether they exist at all. So user can ask Alice, I want some burgers, and they need to decide whether there is a skill that can deliver these burgers. So this scenario actually competes with lots of other scenarios, with generic search over the internet, with search over the organization, maybe with chit chat. Alice may just propose to cook these burgers or to order them in some place without proposing the place, or some other thing. And when we want to actually search over skills, we can search over skill titles, skill descriptions, and even over the past dialogues within skills, what is actually done with this scenario. And when this skill discovery scenario works on its whole power, it could provide people with lots of high quality skills if they exist. And also, when we talk about external skills, they're made by people outside Yandex, and you need to work with people. So these people usually want to somehow earn money with these skills. So Yandex needs to provide the schemes for monetizing these skills, like embedding the advertising in it, or a process called Alice price, just like Alexa price, but smaller and more regular. It's quarterly, and it gives money to some selected high quality skills based on some product metrics of these skills. And in general, Yandex needs to do lots of community management, like responding to skill developers, creating events for them, and providing them good developer experience. Now I will speak not as a former part of the Alice team, but as an external developer which wants more features for coordinating multiple skills. One feature is attaching more priority to the skill discovery scenario, because lots of Alice users currently don't know about the existence of external skills. So maybe Alice will just needs to run this scenario more often, even at the price of a temporary decrease in the quality, because it is a price paid for learning what skills are relevant for what queries. And after it is learned, Alice might be able to recommend them with high precision. Some other idea is to mark some requests to skill as preliminary. It is actually what Alice has been doing for internal skills for a long time. So before actually selecting a skill, we can send a preliminary request to it, and the skill has to report their confidence in the response for such queries, or maybe even refuse to respond. Then another skill would be selected. And the response to such requests may be discarded if the Alice dialog manager decides not to choose them, and therefore the skills shouldn't change the state of the external world for such requests because maybe these requests will never get processed. And if this process is introduced, it enables to actually probe several skills at a time instead of choosing them beforehand. Because actually, if the skill is new, there is no way to know for sure whether the skill can provide a good answer for a query, and the best way to learn it is just to try. Another idea is to pass a global context to all skills to be more aware of the where in the dialog they are activated, which is also which has also been done for a long time for internal skills. So to do this, the dialog manager needs to remember all entities from the last key dialog turn, maybe even to label some relation between these entities or their rules, like distinguish between the point of departure and destination. And it's a very good idea to create chains of skills working with different functions. Maybe sometimes Alice will actually do this. To wrap up my presentation, I want to make some conclusions about what I felt to work with Yandex Alice. And this work was different from I expected or from what you might have expected with working with an AI system. And this difference is because there are hundreds of skills and there are multiple skills to work, multiple teams to work on this skill simultaneously, and the scenarios compete with each other. So you cannot just simply choose the correct one. And there is a high standard for product quality. So when you try to release all this, you need to prove that your scenario is a high quality and that it doesn't interfere with other scenarios. And we are very far from making the assistants really intelligent, because every particular skill now only can do some very narrow job. And when we create each new skill, we often need to reinvent the wheel, reinvent the dialog management for a new skill. And another thing that I learned is a quality assistant requires a lot of old good engineering, like just make it work reliably. And actually, it's fun. And the result, the Alice voice assistant, is far from perfect, but it's still satisfying. It's still much better than most other voice assistant, and I hope it will get better. Maybe it will even get better when you have
Just
right skills for it. And if you are not, still can write quality skills for other assistants using DeepPavlov. Now I think it's time for questions.
David, what do you think is the next future stage for development of AI assistants in 1 year, and what we can expect in 3 years?
Well, I don't expect. I hope that probably we will learn to create skills which are a little bit better than what we have now. Maybe we'll make some more integrations with different businesses, different services and scenarios. But I don't expect some abrupt changes. Well, maybe maybe the assistants will get a little bit more multimodal, because that's what we have seen with Bear, that their new device Sber portal, if I get it right, is already working with video and with gestures, and there are some other voice assistants which are already not voice. Actually, Yandex has released its new Yandex station, which also has some visual interface which can reflect emotions. So I believe we are moving in this way, and maybe the communication with assistants will get even more multimodal. And I hope that in 3 or 5 years there will be some change, after which it will be much easier to actually teach assistants new skills without programming or without pseudo programming with no code tools, just by telling them what we want. I hope that there are lots of progress in NLP, in actually understanding complex commands or generating some complex texts, and maybe it will reach the points when we will be able to program the assistants by talking to them. I don't know whether it will happen within 3 years, but I'll hope we will do it. We in
Thank
the
you.
broad sense.
Thank you. Very nice thought about this learning assistance. I think that many people in industry thinking in this directions right now. But it's still not solved in technology. I mean, and in scientific side. So maybe 3 years is not enough. But actually, people are looking for that. For example, it was a few weeks ago there was a conference, Sociomed conference, which is organized by Young Goodfellow, and there was a workshop which was organized by Jason Williams from Syria. He was in Microsoft Research, and now he is chief manager for Syria, and he mentioned exactly this problem of can we create technology for agents to be trainable to perform some tasks as one of the problems in the field. Okay.
Misha, if you can share the link to this workshop or something like that with the audience, I think it would be rather appreciated.
No, they have no links. I think it was just like it's a social conference, so it's no formal presentations or something like this. It's more like a panel where people just talk and
There were no
nothing.
recordings?
No.
Yeah, that's one of the most interesting things. I mean, what I like about the community calls like this one is when we can not only talk about the product updates and so on, but also can talk about the problems that we are trying to solve from different perspectives. This, I believe, is the most invaluable experience. It's one thing when we can have chats one-to-one, but when we can grab several bright minds into the same room, magic happens. I specifically asked David, by the way, to talk about his experience at Yandex with building multi-skill AI systems, not just because it's interesting to learn how Alice is built, but because there are just a few multi-skill AI systems out in the wild. And we at DeepPavlov believe that one of the ingredients, not the only one, but one of the important ingredients of building successful AI systems in the future is having them componentized into multi-skill systems. We don't believe that users have to remember the name of skills like it is implemented at Yandex or Alexa at Amazon and other multi-skill AI systems that we have in the general public availability. And solving that when you have lots of skills, hundreds or maybe thousands of skills, is really hard. I agree that we need to be able to pass the context did, but I wonder what should be done to better understand to which skill we should provide the control to. How we can know about them in advance? What do you think?
I think that one, first we don't know it in advance, and we need to try, and we need to collect some data. Of course, it's difficult because we can show only one option. It's very difficult to get it from the first shot. The problem with which Yandex has started the search engine is much easier because you can suggest 10 options in the search engine result page, and if just one of them is relevant, you are already lucky. And with voice assistance or dialogue assistance is in general, we cannot afford it. So we need to experiment, and we will do it better if this experimentation is cooperative. If the assistant could go to skill and ask in advance whether hello skill, can you answer this or not? And skill answers, I can answer it with 7% confidence. And if there are some skills with higher confidence for this particular query, they must be selected. And maybe we could invent an algorithm like auction. So we can punish the skills which report high confidence and then provide poor answers, poor by human evaluation. So using technique like this, we could actually incentivize providing reliable confidence. So getting it high if the skill really wants to respond, and giving low confidence if the skill is not sure that response will be good.
Right. Right. This is funny. First, yeah, obviously, when you have a system that is working at big scale, these numbers about human evaluation and so on, they can be really useful. But if you have a smaller number of skills, then perhaps you have maybe more control over this kind of stuff. In the last time when we were participating in Alexa Prize 3, we used confidence as one of the key ways to understand which response to get. So we had like a couple of moments. First, when we get the user query, they all go to skill selector, which makes a decision which skills should run. Because even though we don't have like 2,000 skills like Alice has, or 100,000 skills like Amazon Alexa has, we still have some number of skills and we don't want to run all of them every single time. And after skills generate the hypothesis and provide them back to response selector, we wanted to use a confidence level. The problem was that when we decided to rely just upon the confidence, we had retrieval skills, like one based on Reddit. And Reddit usually has something to reply on any single query from the user. And it turned out that its ability, there is no simple way. You can use some very simple algorithms for text similarity and so on, but they might not always be the best way to measure the confidence. So in the end, we decided to use a rule-based response selector, which not only used confidence, but also used other aspects, other annotations in the system. But yeah, the confidence is like is a beginning of what could be done here. Okay, go ahead.
Yes, one thing is confidence. Another thing is just to use a cascade to group the skills into levels manually. And starting from the highest ranked group, try to apply the skill with highest confidence from this group. Yeah. And that's approximately what was done in Alice when it started. So there were lots of specific scenarios which had higher rank in this hierarchy, and search and general conversation, which work as a fallback scenarios.
Right. Huh. But as far as I remember, those that highest group was like internal scenarios, and then the lowest thing was for external skills. Or am I
Mm,
wrong?
n- not actually not. The activation phrases for external skills were in one of the highest groups.
Right. Right. Well, whatever it is, it's still a challenge for us.
It's still a challenge, but there is a thing that you in DeepPavlov do and that guys in Alice do. They try to predict the quality of each of the responses and rank the responses based on this predicted quality. And I think it's also a very good way to evaluate them. And the confidence reported by a particular skill can be a feature for the model that predicts the overall quality of the response.
Yeah, it doesn't have to be the only reason. It can be one of the features.
Yeah,
exactly. And what I like in your words is that you can use a prediction of quality as one of the features too. Because this is where it becomes tricky. I heard somewhere, I think maybe a couple months ago, that while we are all very far from AGI, which stands for Artificial General Intelligence, autonomous vehicles or self-driving, in other words, these groups are closer to AGI than anybody else, probably, because they have to solve a lot of problems. One of the things that particularly stand out for me was that a self-driving system not only has to map the world as we know, but it also has to predict what's going to happen in the next few seconds because it has to plan accordingly. And if you want to build a smart AI assistant, you not only have to think in one step when you think about what's going to be next, but you also need to know how the user will react. And you can't know, you can only predict. So you also have to make a thin prediction of sorts. Not maybe as complicated as it happens for self-driving, but in the very same time, it's more complicated because in self-driving, you just have cars moving in some directions, cars and people, maybe birds, maybe flying books or whatever it is. But more or less, the rules are very simple. And in conversation, user can go wherever he or she wants, and the prediction of the thing is harder. So with all of that, I think it's a good time to let Oleg, our developer of the Gobot framework, to have him the audience and continue conversation about Gobot. Let me share just one screen before Oleg will start.
Sure, and I had a quick question to David. Well,
Okay.
If you don't mind.
Yeah, please go.
Well, I just saw in my GitHub newsfeed that you have a repo called Dialogic Dashboard. What's its purpose?
Well, it's a dashboard to look at the logs of the Alice skills created with the package that I use for them. This package is just a Python package for my personal use that maybe one day I'll turn into a public library, but I still feel it's has
Sure.
a lot of
Okay.
things to improve in it.
I just got impressed by the title.
Mm-hmm.
Thanks. Okay, so Daniel, do you have something to say, or I just should start screen sharing?
So what I wanted to say is, our library just shipped like maybe half an hour ago. You can go and grab it after this community call. That's thing number one. Thing number two is everything that Oleg is will be talking in a minute is available in the library, together with documentation doc.deepavlov.ai. And also, you will be able to use the same tutorial to integrate it into your goal-oriented skills built on top of our DP. You can go and grab DP distribution called DP Gobot base on our DP repository at github.com/deepmeat/base and use that stuff on your own machine. And with that, I'm giving audience to Oleg, and I'm very happy to see Oleg again joining us as it became usual. We work really hard on goal-oriented framework called Gobot, and Oleg is during is like he's exactly that kind of giant that this whole thing is staying upon, and he's a very brave man. So, without further ado, welcome to Community Call.
Okay, thank you for your warm intro. I will be sharing my screen, and well, it probably started. Okay, so yeah, what I'll be showing is a tutorial. Well, actually, well, I probably will start with a short agenda for my many times shorter speech than the one that was before. But and probably some of you saw some stuff that I'm gonna cover. But anyways, like, well, right now we are working on extending our goal-oriented bots with lots of useful stuff, like the stuff that is inevitable to have in your pipeline. For example, you probably have your APIs because like if you're having a goal-oriented system, well, you probably have some business logic to fulfill, and it is usually realized with APIs, and these APIs do rely on some information, so you have to query them with the proper like slots or intents or like anything. Well, you have to collect some information from the user, and there is a task called form filling, which I covered in our last call. And well, today I'm gonna just go through the form filling tutorial we just saw a month ago, but it will be a bit deeper, and I will be like a bit more, well, I will be covering it more like more well thoughtly. So what's the point? Well, we just had a release in an hour ago, and we have a tutorial called, it is called like, well, we have a tutorial folder. I just picked the wrong one. It is called form filling demo and form filling tutorial. And this is the one I will be just showing you in the collab interface. Well, we just lost the badge collab. So back to the form filling. Well, I just covered the task of the form filling. So you have some API to query. You have to collect some knowledge to pass to your API, for example, via some like REST calls or something like that. And in order to collect such an information, you probably could like passively wait for the user to inform you with all the information needed, or you could be a bit more proactive and like ask the user for the information you still need, and well, without thinking about the stuff you just received. So that's how form filling should work, like, and that's how our form filling works. Like you have to understand which slots. Well, we will be talking about slots. Well, you have to decide which slots you are willing to receive from the user, and in order for your API call to succeed, for example. And well, since we have nearly New Year, we'll probably see some funny animals. No funny animals today in Google Colab. Okay, well, anyways, I was thinking about animals when I was building this tutorial. So I will be thinking about, okay, I have an like API of the database of all the zoos in my city, and I will be trying to understand, well, which animals does my user trying to like find in the city, and which time it would like to go to the zoo. And so in order to respond to him, well, where should he go, or where is the place he's looking for, where is this place located, I have to understand which animals is he interested in, and which like which time of the day, well, which time is he interested in. So I will be collecting these two slots. Well, the first one called animal, the second one is called like time. And for example, well, to define a form, you have to like write some configuration files. Actually, just two of them. The first one is called domain email, and the second one is called stories. And well, it's Markdown or email depending on the Rasa version. And well, when I'll start with stories. If you have a story to just, well, if you are working with within our Rasa DSL pipeline, you have to write a story defining what happens in your dialog. For example, well, just below we see the story that is start. Well, it defines a scenario when just the user says hello, hey bot, and the bot should understand, okay, we're just now filling the form in order to perform an API call, and the bot starts asking about the information that is needed to perform this API call. And when this slot filling completes, when this form filling completes, when all the information needed is collected, we finally can perform our API call. So we define it as a greeting intent from the user. Intents were just covered in the like brilliant talk by David. And well, so we have a user utterance which is classified into greeting intent, and we should respond to it via the form filling action defined by the zoo form. And after the zoo form completes, we are finally able, and we want to perform an API call. So, well, that's what we're willing to do, and that's how we write a story. And well, I just mentioned that we have a form which has to be completed, which has to be filled. And the forms themselves are defined in the domain email configuration file. It is consisted of various sections. We'll be able to see this just a bit later. And it has a section called forms. You have that's just a dictionary, and you have a section. Well, each form is yet another key in your dictionary of forms, and you're just listing these in this form all the slots you are interested in. So, for example, in this small toy example, I'm just interested in the animal slot. And well, if you are trying to build a bit larger API, for example, today we are going in this tutorial we're actually covering 2 slots, so you have to list another slot here just below the first one. And that's how you define your forms in the domain email. And that's all you need to make your forms working. And well, another large milestone I am working towards is like seamless integration with APIs. So you probably, well, in some future in our roadmap, you won't be even thinking about implementing your API calling logic, because it's probably like easy to understand somehow. Well, anyway, so you have, well, we just covered the configuration files, so let's go and write them. We'll have a directory in which we will be working. I usually call it dpminimal demo-tier. That's just started this summer. And like we will have the story, we'll have 2 examples of dialogues. So sometimes we're just saying hey bot, and the bot responds with hello, and sometimes we are saying hey bot, and the bot understands that we actually are doing some business logic, so it starts to fill a form, and that's probably the start that should work. So well, let's start with this simple scenario of 2 stories, and like, well, I will multiply them because we're like doing machine learning, so I have train, test, and validation splits, but I'll just copy paste this. Anyway, so we have some intense classification. Well, we have some intense classification training set defined in the Rust DSL language. It is called, well, it's written in the NLUMD config. What is interesting here is like I'm not sure whether we had ever shown before that you are able to define your slots slot training set in this like markdown like format. So here I am defining that there is an entity called cat, and it is belonging to the slot class called animal. So that's how I build a training set for slot filling component, and that's just the sentence, which is like, I'm looking for a cat, and I just marked up that cat is an entity. So that's just this plain text sentence. And well, I'm just training the slot filler, and I'm training the most naive date parsing logic ever. So I have two types of time slots. It is either evening or morning, and I'm training my slot filling system to extract this slot based on these examples. And that will probably be enough to train the intents classifier, well, the domain email. So, well, actually, the domain email consists not of forms, not only of forms, but actually we have to list the response templates. That is, if we are saying, okay, so we just understood that the system has to respond with an action or with some the system has to say a greeting. We could provide here some examples of how does the greeting happen, and it can be picked. For example, one could pick one greeting or another, and we have a slots section that lists these slots I just mentioned in NLUMD config. Well, these slots are just listed in order to understand, well, which parts of Markdown are slots and which are not. And I have an action. An action is a unit of the business logic. So you write your API interaction logic. That's usually just like requests based stuff like get and etc. And you could probably skim through the documentation to know a bit more about actions. And well, we have three types of intent. So user either greets us or it informs us with the information of which animal or time, well, of which time of the day he's interested in. So that's just the classification, the classes of user utterances listed here. And the form itself. So again, I'm just reminding that we have actually two slots that are to be filled in order for a form to succeed. So, well, let's write this file too, and sure, this sounds a bit more adequate. And if I remember correctly, I just installed all this stuff, so it will work in just a second. Yep. And let's import all the stuff that's needed to train the DeepPavlov component. And we will have a slot filling component. That's the minimal slot filling configuration on the DeepPavlov framework. So we have some input data, and it is tokenized lowercase, and then we're learning our slot filling to extract the animals and the dates from the goal-oriented bot. So let's just see how it works. Well, I hope it will. Yep, it trained it just in a second. So, well, I gave him a sentence and it responded, okay, I see a slot here, so not for a fish. Well, it still sees some slots, and well, I never provided fish as an example of an animal. Like fishes aren't animals. Well, that's just slot filling component work, and I just played with it a bit to ensure that everything's working fine. And we have a goal-oriented model config that is slightly larger than the slot filling configuration file, and we have lots of these in our DeepPavlov library. They are just in the package deepavlov.configs.goal-oriented-bot. We have various examples of goal-oriented bots configuration files. We have the simplest ones and the most sophisticated ones. You could just pick the one you love. Well, so let's finally actually install this stuff too, so it will probably again just work nearly momentarily. And so, well, anyways, the most interesting part is to train the goal-oriented bot based on these configs we just saw earlier. So just to remind the stuff that is going on, we are training our system to extract slots from the user. So we know that we are willing to make an API call that relies on 2 slots. So we want the user to provide us with these slots. So we need somehow to make him like to feed us with these slots. So let's try to build a simple conversation with the user. So how it will work, like I will simulate the conversation with like asking him, the bot, with some information. I have a start intent that is reserved in order to allow for like goal-oriented systems to start the conversations themselves. For example, if you have some business logic that needs your bot to start the conversation, you just querying the bot with the start token and it starts the conversation itself. Well, anyways, we are starting the conversation and I'm greeting the bot and I'm saying that I would love to go to the zoo, and I'm saying which animal I'm interested in and which time of the day I'm interested in. And well, when he receives all the information, it would be probably a bit more easy to read if well, I'm saying start, he says, okay, we are starting the conversation. I'm saying hi bot, and I'm saying that I would like to go to the zoo, and he understands, okay, so in order to perform a zoo API call, I need to know which animals you are interested in. And I'm saying, okay, I'm looking for cats, and it understands, okay, we know now which animals he's interested in. So the last thing we wanted for him to provide us with is the time of the day. So I'm saying, so it's asking me which time I'm interested in. You could pick plain text versions of these intents of these response templates in the domain email. I just left these because they are like smaller and easier to read from the screen. So it asks me about the time which I'm interested in, and I'm providing it with some time slot example, and it understands, okay, so he provided us with all the information needed to perform an API call and performs the API call. And what is brilliant, I'm just able to say, okay, I would love to see a wildcat this evening. And it will, well, the conversation became shorter and it asked me about the animal, and I provided the bot with the animal information, and I also mentioned another slot, and it understood, okay, we now know all the slots that are needed to perform an API call, so we are just able to perform an API call just right now. We don't need to ask the user for the information which he just provided us with. So that's the strength of the like form filling components. They are just, well, they work until they fill all the information they were interested in. So that's basically all the demo we have in the DeepPavlov, like in the current release. And if you have time, we could play a bit with and write some a bit larger board. Well, probably introduce some other intents or stories. And if we don't have time, so it's up to Daniel to well, Daniel, do we have time for some a bit deeper example or not?
Well, this is a big question to the audience, I think. What is it now? It's 8:41, so we are way past our typical 1 hour and 10 minutes.
Wow.
To run this whole thing before. So, folks, feel free to click on yes if you want to have a bigger demo, or no if you feel that you're tired and wait for this.
Well,
yes.
anyways,
yes for now.
And by the way, guys, when I'm like, I just opened the chat on the screen. Do you see my Zoom chat?
Yes, if you also want to ask questions to Oleg, it's a great opportunity. And again, I just want to highlight that we've been showing lots of things about Gobot and in the past, but now you can go grab and clone a system-based repository from our organization at GitHub. And you can also use Gobot to build goal-oriented skills for a multi-skill AI system based on this repository. You can also use form filling starting with today. And we are very anxious to hear your thoughts and get your experience and learn what kind of things we probably should implement in the next versions of the system. If someone wants to play with Intent Catcher, that we also released earlier today, you can try it out separately. Or if you are brave, you feel that you're brave, or like we said at Google once upon a time, if I feel lucky, you can try to integrate our Intent Catcher into Gobot as well, instead of the built-in one, and play with this kind of stuff as well. If you want to play with this kind of stuff, we may have some gifts with DeepPavlov on it. So you can think of it as a small kind of contest of stories, and also experience with it as well. So we have 1 yes for now, and 16 other people, maybe less, because we have 3 co-hosts, are saying nothing. Let me ask the same question in chat. It will help.
I actually didn't hear you well. Okay, so maybe something was wrong with my connection. So the tutorial I was just covering is located in the examples directory of the DeepPavlov library, and like, well, the larger example, anyways. Well, not to waste people's time, I just will show the second screen, probably in which the stuff is written and train it. So I'll just to remind how stories are written in the DeepPavlov framework. This is not the part of the tutorial because it consists of the stuff that was covered earlier. So if you want to introduce some other intents, or like, for example, if you want to say that if somebody just says that he wants to go to the zoo, we should start the form called zoo form. If we are talking about like, if somebody says, I just love animals, we just say, cool guy. Well, and that's not about he's wanted to go somewhere. So right now I'm just introducing the intent that is not related to the form filling, and I'm just doing it with, we're adding just another story to allow for users to to avoid interaction with form if the form filling is, if the API interaction, if your business logic interaction is not the stuff that should happen in this way. Well, and then the stuff is basically the same as before. Like you are defining what is your wanna go zoo intent, and what is your greeting response template, and what is your inform animal intent. So, inform animal is we just saw the inform animal intent. Wanna go to the zoo intent is just yet another example of the intents classification. Again, David probably covered the intents classification many times better than I am just doing in my short talk. So, and that's all that you need to do with the example you saw in the form filling, in the basic form filling demo, to make your bot a bit more like real life looking. You are introducing the various paths that your system could follow. And again, if you're writing the same, the domain email just stays the same. You're just introducing the new intent to this, and while interacting this with the system, we now can see that if you are saying, I want to go to the zoo, it starts the form filling component, and then it performs an API call. And if we don't providing the bot with this information, it just doesn't start the form filling component unless it understands that, we did everything that we could do. Probably user finally still wants to do some business logic. That actually was everything that I wanted to show. So the main point here is just to enlarge your systems. You just have to write a couple of lines and the rest stays the same. Okay, thank you, folks. If you have any questions, feel free to ask. Well, feel free to drop them on the screen or like write them in the chat. I will stop sharing for a moment.
And I want to say thanks a lot for giving a demo today. And we are super happy that we have the stuff already available, so you finally can go and pick up the stuff, download latest version DeepPavlov library, and DP, and so on.
Yeah, sure. That was just a rough month. We did lots of production work with DP agents. So
yes, that's a crazy thing. It's one story when we build things for Alexa Price, when everything we build is all about one competition. But when you have customers that you work with, you suddenly grab lots of problems. We have to solve them, and we also had to simultaneously ship the release. So it was a rough time for us. Still is, and yet we managed to release the thing. So, folks, if you have questions, it's your time. If not, I don't know, we can stay here for a few more minutes and then probably get this call to end. We all want to say thanks for all of you, for joining us today. I want to say thanks to David, who joined us earlier today with his talk, to Oleg for his demo, to Mikhail, obviously, for his questions, so for everything you've done for getting DeepPavlov, for transforming DeepPavlov from dream to something that is building a community around it, not mentioning the library itself and the team and all the challenges and so on. We have a crazy plan for the next year. Next month, we are going to refactor library. We are going to make decisions which kind of models we are not going to support any longer, which kind of models we're going to support in the coming year or so. We will continue bringing Alexa Price components into the library. So, for example, right today, we shipped intent catcher, which we showcased a couple times before. And intent catcher is one of the things that was built for Alexa Price 3. And it is in the library today. And in the coming releases, we will ship more components from the Alexa Price into DeepPavlov library as a basic components available for all of you. You can use them for multi-skill AI systems. You can use them for other kinds of NLP applications. And we are thrilled to ship in more things for you in the next year. Thank you very much. And Happy New Year and Happy Christmas.
Yes, Happy New Year, Happy Christmas, Happy New Year. Be happy. Don't worry. Use DeepPavlov and you will have less worries, maybe.
Okay, thank you to everyone and see you next year. Good luck.